Hi, everyone. My name is William Rodriguez Jimenez, and today I want to present my research on understanding electric vehicle owners' preferences towards enrolling in smart charging programs. I wanted to start by presenting the underlying motivation of our research. The demand for and consumption of energy has been rising steadily around the world in recent years. There's no sign of an immediate shift in this trend, so energy infrastructure should prepare itself for the years ahead. This preparation, though, should be thoughtful to better incorporate renewable energy and prevent the expansion of climate change. Now, if we focus more towards the micro scale of things, we can analyze the trends that contribute towards energy consumption and demand. Demand for energy in cities generally follows a trend that we've illustrated here as a rough estimate over the 24 hours in a day. Demand for energy picks up in the morning as people begin their daily routines and businesses begin to open. As the afternoon phases in, we can also observe another incline in demand for energy as people return to their homes and turn on appliances for heating or cooling, cooking, and entertainment. Now, if you add electric vehicles or EVs into this equation, the projected energy demand can increase significantly. How do electric vehicles fit into this curve? When does EV charging actually occur? The literature on EV charge patterns indicates that there's a strong trend of afternoon or evening charging for electric vehicles. After completing their daily commute and getting home from work or another routine, EV owners plug in their cars and leave them charging typically towards the next day. This leads to marked increase in demand for energy that must be met by energy markets. This is represented with that red area in this graph. This represents the charging EVs. Electric utilities, however, want to avoid these spikes in energy demand due to the additional constraints that are placed on saturated grid infrastructure when this happens. This is why utilities implement time of use or TOU rates, making energy delivered in times of peak demand more expensive. But what if we could avoid this burning peak of red that pushes the grid to work its hardest and for consumers to pay the most money out of their pockets? Smart charging for electric vehicles attempts to solve this problem. After a vehicle is plugged in, smart charging reduces the rate of energy charge or reschedules the time of when an EV charges from the early evening when people plug them in to the late night and early hours of the morning when electricity is less expensive and the grid is less congested. Smart charging is accomplished through intelligent communication channels between utilities and charging EV infrastructure. Smart charging promises to prevent expensive peaks in demand for energy and save money not only for the EV owners who charge their cars, but also for the stakeholders that service and maintain the grid. However, it's not really fully known or understood if EV owners would actually want to enroll in what we call smart charging. There are many valid reasons as to why someone would not want to immediately charge their vehicle when they plug it in. Most obvious among the EV community is range anxiety, or the fear that you'll end up with an empty tank while driving, not be close to a charger, thus incentivizing the need to charge as much as possible when you can. But what if you need your car when you leave to work in the morning? EV owners might be hesitant to have their car charged later in the evening instead of when they plug it in case an emergency comes up earlier. Additionally, there is lack of information bias. If you don't know what smart charging means, what it does, or how much money you could potentially save with it, you are potentially less likely to enroll in it. As researchers, we pondered upon these questions and looked for ways to obtain descriptive, quantitative answers. We identified bidding contingent valuation as a feasible method for our research. Contingent valuation is a survey-based economic method and involves using surveys to elicit the willingness of respondents to pay for hypothetical goods or services. There are many ways to conduct contingent valuation, but this generally depends on the way questions are asked. Specifically, there's a form of bidding contingent valuation, which a survey asks respondents to value a certain good or service. Specifically, they ask a participant if they're willing to accept or deny a good at a given price level. You can have increasing or decreasing bidding contingent valuation. For example, you can ask someone if they would be willing to buy a good, let's say A, at $10. In decreasing bidding contingent valuation, if they say yes, then you lower the amount of this good A, let's say to $5, and then ask the same question. If they say yes, then you again lower the price until the person denies the good. By doing this, you establish a bound for the given good that you're trying to estimate the value with. And in this example, for example, it lies at $1. After giving careful thought to our research intentions and seeing that contingent valuation was a feasible quantitative method for obtaining the information that we were looking for, we aligned our fundamental research question. We know that with smart charging, at least from the owner's perspective, one of the main objectives is to save money on a monthly electric bill. With this in mind, our fundamental research question thus evolved to: how much money do electric vehicle owners need to save on a monthly basis in order to want to enroll in smart charging? How much money do people need to save on their monthly utility bill in order to want to opt into smart charging? To answer this fundamental question, we developed a web-based preference survey that employed bidding contingent valuation. We architected the survey in the following manner. In the beginning, the survey had a short introduction, followed by some commuting questions. In this section, it was determined into learning more about the person's commuting profile. This was with the purpose of better tailoring future questions to this respondent. After providing their information, the survey asked respondents to imagine that they had just purchased an electric vehicle and to answer the questions that came afterwards with this in mind. Next, we had the most important part of the survey, the actual bidding contingent valuation section. In this section, we asked participants to compare two charging options. One charging option was meant to capture normal EV charging, and the other, smart charging. The core questions in the contingent valuation section told respondents that with their first option, their car immediately began charging once plugged in. The survey specifically shared how much money EV charging would contribute to in a monthly electric bill, along with the typical charge finish time in relation to the time of which this respondent typically displayed that they arrived home. We programmed the survey to calculate these amounts in accordance with the commute pattern indicated in the previous commuting profile section. For the second option, identified as the second column to the right in this slide, you can see that the survey told the participant that their car would be charged when electricity was inexpensive. Furthermore, it explained that charging would conclude 1 or 2 hours before the time in which the participant indicated that they typically leave to begin their daily commute. This 1 or 2 hour amount was randomized among respondents to test time sensitivity. Other elements of the survey were also randomized, such as the label of normal versus smart charging, which was also on display as option A versus option B. In these questions, the survey indicated an amount of money that the participant would save on a monthly basis by opting into smart charging. The participant then had to choose which option they preferred. The survey repeatedly asked this question in the form of contingent valuation, changing the savings amounts to determine exactly how much money the participant would want to save in order to opt into the smart charging or option B preference. In all, we distributed this survey to 241 EV owners and 202 non-EV owners. The EV owners were invited to the survey through different online Facebook groups for EV owners in different states. Think Tesla owners of Massachusetts, for example. These had no financial incentive to complete the survey and were classified as targeted respondents. On the other hand, you had the non-EV owners. These people were obtained through the Mechanical Turk platform offered by Amazon and did have a financial incentive. They were given $1 to complete the survey. We classified these as random participants because they were not EV owners. Now I wanted to go ahead by presenting the key findings to our studies. A huge finding with our results was that we obtained overall high participation in smart charging. 84% of people chose to participate in smart charging for at least one amount of savings. And this was comparable among both the targeted and random populations. And most of these chose to opt in to smart charging for low monthly savings of $5 or less. Next, the way you call things matters. We obtained the highest participation rate in smart charging by calling it like that, smart charging, instead of option B. Moreover, we saw sensitivity to buffer time between the time in which smart charging's finish time would occur and the person's regular departure time in the morning of the next day. 7% more participated when offered 2 hours instead of only 1 for smart charging or option B. As your schedule gets more unpredictable, you are less likely to enroll in smart charging. This minimum reservation density curve illustrates the minimum amount of money our participants needed to enroll in smart charging. You can appreciate that most people are concentrated towards the lower end of required monthly savings of only between $0 and $5. You can also see a blue bump on the left with the 2-hour buffer option, underscoring the willingness of people to enroll in smart charging for lower amounts when given more time with a fully charged battery. So, what should you take away from all this? If you're an EV manufacturer or utility, or generally interested in innovation, implement smart charging. People will participate for low savings. Second, if we implement smart charging, this could lead to more EV adoption as lifetime costs of owning an EV would be reduced. EV manufacturers could sell this advantage to potential customers. Tesla already does this in sharing a final price for their cars on their website. With smart charging, we will have an overall smarter, more efficient city. And finally, with more EVs, this will dampen our dependence on petroleum-fueled cars and accelerate the transition to emission-neutral electric cars, tackling climate change head-on. Thank you.